Objects and Classes, Part 2. Without any delay, let's jump right over to the code and pick up where we were last time. So as a quick reminder, we talked about how we can make these different types of data in Java. X equals 7, an integer. Java understands what X is, it's an int. Double Y equals 3.94, or a Boolean or a string, all of these primitive data types, and even a string, which is an object. Java understands those things, right? So what did we introduce last time was the idea of, well, what if we typed student S1? Now, currently, the code is working because we created this blueprint. But what if we had typed here, for example, employee E? What is an employee? Java has no clue what an employee is. In that same vein, Java has no clue what a student is. So what we did last time is we introduced this idea of creating classes, creating blueprints. And we created this student blueprint, which had many data members. And then after creating this student blueprint, we were able to create an object of type student. We zoom in some, we created this object of type student. We then added data into this object of type student. How did we save data into that student? By using this dot operator. I would say S1, which is the name of the variable chosen to store the reference of that type student. And it's worth a reminder to go back to the actual tablet here and to see when we make this new student object right here and we say, yo, Java, make me a new student. What happens is, remember, this is an assignment right here. It's an assignment. So we start on the right side. We make the student object. All of the data members get default values. And then what happens is the address of that object gets saved right here. The address of that object gets assigned, gets saved into the variable that I happen to call S1. The consequence of which is S1 then stores the address of this new object that we created that is now on the heap. So we did this last time. We created these new objects. We saved data into those new objects using that dot operator, and we also then printed the data from those objects. The final thing we did is we made multiple constructors. We made a second constructor here and even a third constructor here. As a reminder, what is a constructor? Is any time that you say, let me come way down here, any time that you type something equals new something, what is happening when Java sees new? This is a command, yo Java, make for me, construct for me a new blank, a new, maybe it's going to be a new scanner, maybe it's going to be a new random object. Maybe you would have said, yo, Java, make for me a new string, because it's kind of weird, but we've talked about how you could say, instead of saying string name equals Kayla, you could say instead string name equals new string Kayla, right? So anytime you see new, let me get rid of this. Anytime, let me call this name 1 since it's already been defined. Anytime you see new, this is, yo Java, make for me a new object of what data type? The type that's being specified here, this particular string. So we made new students and we sent over to those constructors a different set of parameters because we made different constructors. So here, the second constructor, we actually sent over all 6 parameters to save values into all 6 of those data members that we had created. So we have these 6 data members, and we made a constructor that received 6 parameters: an ID number, a first name, a last name, an email, a phone, and even a double grade point average. And when we called that constructor right here, and we sent over all 6 parameters, it kind of feels like calling a method and sending over 6 parameters to that method. When we did so, all 6 of these parameters were sent over to the constructor, and the constructor, we then took each one of the parameters one by one, and we said, yes, let's save the parameter ID number into ID, the data member of this particular student object. Let's save the fname parameter into first name, the first name data member of this particular object. And so we did all of that within the constructor. So instead of creating a student with the default no argument constructor and then manually assigning 6 pieces of data into those 6 data members, we then in our constructor sent over 6 pieces of information, and then here within the constructor we assigned all of the data. And then finally we printed that data, accessing it once again using the dot operators. That was a reminder of the summary of what we covered on the previous video. And we said that what we're going to do different on the next video, which is right now, is we said that we're no longer going to use this dot operator. In fact, the idea of using this dot operator is only done to allow that first discussion of OOP, of classes, and then creating objects from classes. It's only done using the dot operator to make that discussion more palatable, easy to understand. But in fact, starting from right now, we will no longer be using this dot operator, and let's talk about why. So I'm going to go ahead, and I've already made a new project that you should make as well. The previous project we had was called OOP Intro that you see right here. You should make one called OOP Demo. So go to File, New Project, make a brand new project, call it OOP Demo. And here we are. So go ahead and do that and pause the video if you need to. Make a brand new project called OOP Demo. Once I'm here in this project, I'm going to come over to the default package. I'm going to right click and I'm going to make a new class. And I'm going to once again call this class Student. So this is going to look pretty similar to that previous project we had made at the beginning. So I'll hit finish. I've made a new class called Student. And let me delete the default comments made from the template. So now you can see on the left, I have OOP Demo. I have oopdemo.java, which is right here. And then I have student.java, which is right here. If you have another student.java open, that's simply the previous student.java from the OOP intro. If that's confusing, feel free to close both of those. Let me go ahead and hit save here. Okay, so what I want to do is I like to start by, once again, inside our student blueprint, our student class, put a comment, call this data members, and let's make only 4 data members, and you'll see why we're going to limit it to just 4. Let's use those same first 4, int ID, string first name, string last name, and how about we call this double GPA. Now, let's also go ahead and make a constructor. Let's make the default no argument constructor. Default no arg constructor. So here, just public student, and we won't even put anything inside it. No harm, no foul. And let's even make one other constructor that expects all 4 parameters. Public student, and let's say int ID number, string fname, string lname, double grade point average. We typed all of that out. And if you want, you could go have copied this from your previous program, but it's good practice. Just type this again. So now that we send over all 4 of those parameters, we want to save them, the parameter ID number, into the data member ID. So I want to say ID equals ID number, first name equals fname, right? So I'm taking this parameter fname and I'm saving it into the first name data member. Last name equals lname, and then finally GPA equals grade point average. Okay, so we have the same class, except we don't have phone and email, which is fine. And we've made two constructors. Let me go ahead and put a comment on this other constructor. Constructor with all four data members sent over as parameters. Cool. So with that now done, of course, we can come back to our main. So I came back over here to OOP demo. And notice I did call this OOP demo. If you called it main with a capital M, no problem. But let's come back to our main, inside our main method. And let's now make a new student object. So student S1 equals new student. And let's even make another student object, student S2 equals new student. And this time, let's send over all four parameters. What are the four parameters? We had an ID, so how about 111, 2222? We need to have a first name. You can put your name. You need a last name. And then we need a GPA, so 4.0. There we go. We've made two students. All right, so until now, this is the same as what we did on the previous video. What was covered on that previous video was after making this vanilla student object with no information inside it, we then said we wanted to assign values to the data members of S1. And we said S1 dot ID equals, and let's go ahead and put the same values or put some other data values, 3333, S1 dot first name equals, and let me pick a new name over here, Addison, and then S1 dot last name equals, no need to type this, don't even type. If you've started, you can stop. Wesley, and then finally S1 dot GPA equals, and we'll give Addison Wesley a 3.8 GPA. And then finally, what we did is we also printed using that dot operator, right? So you know what? I'm going to even, to save time, I'm going to even come open up that OOP intro. And I'm going to take that series of print statements. I'm going to copy it. And I'm going to paste right here. We printed, but I'm going to get rid of email and phone. All right, so here are even the print statements that we did last time. S1.ID, S1.firstname, S1.lastname, S1.GPA. Now, what we said in that video is this dot operator, it's not supposed to be used. And the reason it's not supposed to be used is because we're not supposed to be able to use it. What do I mean by that? Well, right now, when I come back over to student, the only reason the dot operator is currently able to work is because within our main, within our OOP demo, we currently have access to those data members. And the reason we have access to these data members is because we have not limited that access. What do I mean by that? Traditional OOP techniques is when you have a data member that is part of a blueprint, that data member should have limited access. In fact, you should type the word private in front of each one of your data members. Now, as soon as I type the word private in front of that data member, look what happens. Now over here, all of a sudden, NetBeans has underlined ID in red. If you put your mouse to the left and you read, it says ID has private access in student. We can no longer directly access that ID data member, even though S1 is a new student, even though ID is a data member of student, and we've made a new student object. By making this data member private, we no longer have access to edit and update or even retrieve the value stored inside ID directly. And this is correct object-oriented programming technique, where you should make all of your data members private. Now, we will study in a couple more videos the detailed nuances of this, and these are actually called visibility. I'm going to type it, then delete it, so you can just read. No need to type this, but visibility modifiers, which would be public, private, protected, and then the default value if you don't use any of those. So notice, without typing the word public, so I could have typed public right here, for example. I could have said, you know what, ID is a data member and it has public access. What does that mean to you? We'll cover more of those nuances in detail. There's going to be a table shared. We're going to have to memorize that table and understand it very well. What does it mean to put protected? We're going to cover that as well. Protected, we'll cover that as well. What does it mean when you don't put public, nor do you put private, nor do you put protected? Here you have the default visibility modifier, and we'll talk about that. But for now, suffice it to say, all of our data members should have private accessibility, meaning these data members are only going to be directly accessible from within this class. So notice we have two Java files open. We have OOP demo.java and we have student.java. Both of those files are found within the same package. It happens to be just a default package, right? Because we're not making our own custom package. Although they're both found within the same package, these variables, these data members that are part of the student class, that are part of the student blueprint, we just made them private, which means that no other Java file has direct access to these variables. And that's important. This is called information hiding. We would like to hide the information of these variables from other Java files, from other classes, because they are classes. In fact, this is a class, right? It's public class OOP demo. We would like to hide the data in our blueprints from other classes, and you want to make it private. This is the correct OOP technique to make your variables private. The consequence of which is what, though? Now, we can no longer say s1.id. I can no longer try to access the ID to print it via s1.id. So what do we do? How can we save data 111333 into ID if we cannot access it directly? The answer is we need to make what is called accessor and mutator methods. Accessor and mutator methods, aka getter and setter methods. The name should be hopefully self-explanatory. An accessor method is a method that allows you to access the data within a particular data member. A mutator method is a method that allows you to change the data within a particular data member. It's called a mutator method for mutate, to mutate or to change those values. So let's make our very first accessor and mutator methods, or getter and setter methods for this data member ID. So here, let's come to getter methods, also called accessor methods. So we want to be able to get this ID value. Previously, we had s1.id. Well, that's no longer working. Instead, we're going to have to make a method that's going to retrieve that ID and send it back to us. So the method will actually be called getID. And what is this getID method going to do? It's simply going to return an integer. So check it out. Here's our first getter method. It's a traditional method. Public, it's going to return an integer, getID, and what does it do? It simply returns ID. So ID is the data member up here, and we've made a method. It's a getter method. It's called a getter method because it's merely getting for this call in main. When it's getting the ID and it's returning it. That's all it does. And the naming conventions of getter methods are you simply take your data member name and you put the word get in front of it. Let me make the other getter methods as well. I'll make one more, and then you should try to follow along and make it. So the next data member is first name. So if you want to make a getter method, I'll put return type here so you can think about that. What would this getter method be called? It would be get first name. And what do? Return first name. And what is the return type? What is the return type of this method? You would say, well, I'm returning a first name, which is a string, and absolutely the return type is a string. What is let's code up the other two getter methods. Public string get last name, return last name, and then finally public double get GPA, return GPA. These are four methods that we just created, and these are called the getter methods or the accessor methods. What they do, and they're public methods, which means because they're public, that means that we can access them. When I make this variable S1 right here, S1 has all of these four data members, but those four data members are private. I cannot access them directly. I cannot save data into them directly, nor can I read data directly. However, because I've made these getter methods now, and let me just delete this information here. You know what, let me just comment this out. But because I have made these getter methods, now when I want to print the information, I can do this. I can type S1 dot, and notice we have get first name. S1 dot get last name. And then S1 dot get GPA. Now, as you're watching, you might be thinking, okay, that seems like we're doing the same thing. And we effectively are, right? Before we had just S1.ID, S1.firstname. You might be like, well, then why not just leave it the way it is? Why not get rid of all of those getters and setters? Just get rid of them. Come back up here, get rid of private, and all is well. Because that's not how it's supposed to be done with object-oriented programming. We're going to talk more about privacy, about information hiding. These are the most fundamental techniques of OOP, that all of your data members should be private. You should not allow them to be accessed from other classes. And the only way that you should allow access to your data members is strictly via the getters and the setters. So we've coded up the four getters. And what do the getter methods do? Is they allow you to retrieve the values inside those respective data members. So here, let me actually cut this and paste it underneath S2, and let's call this S2 so we can print and see that it works. Let's run this. So we get our output, and in fact, it's working as expected. So we made a new student object with those four parameters that we sent over. And now we are printing the data from that student object that is saved inside S2. We're printing that data, but we're not using the dot operator directly with dot ID. It's not even allowed. It doesn't allow us. Notice it doesn't even show a dot ID, right? You can't even pull it up in the list because it has what? It has private access. We cannot access it directly. Instead, we have to use this getter method we made. So what is this doing? Just check it out. S2.getID. Well, let's go to, what is S2? S2 is a student object. Let's go to the student class and let's look at the getID method. What does it do? It has no parameters. It just says return the ID. That's it. Just return for me the ID. Done. It returns the ID right here. The ID was what? 1112222. And then we print the ID. That's what each one of these getter methods does. So now we're ready to see the next one, the setter methods or the mutator methods. So in the same vein, now we want to, let me uncomment all of these things. Here, instead of saying s1.id, What we really want to do is something like this, s1.setID, and we want to call a method, and that method is going to be public. And when we call that method, we want to then send as a parameter the ID that we would like to be set. So when we come back over here to the student class, let me zoom out just a bit. Remember, we had the data members, we made those constructors, and now we are making the accessor and the mutator methods. We just made the 4 getter methods, and now we will make the 4 setter methods, aka mutator methods. And they're called mutator methods because they are changing the value stored within those data members. So let's start with the obvious one, the integer, the first one, public. Now these are setter methods, so they're not returning anything. They're setting values. So all of them would be void. Public void set ID. And here, since they're setter methods, that means that we're going to be sending to them a value. And I'm going to type in int ID number. And what should we do with ID number, this parameter we're sending? We should save it into the data member ID. So this is a setter method. We sent over to this setter method an ID number as a parameter that we are then going to save or set into the data member ID. And so now, if you noticed, this now works. We can call that set ID method. So instead of saying s1.id equals, we can't access ID directly. Why? Because ID is private. Why is it private? Because it's supposed to be private, right? And so what do we do instead? We make a setter method, a mutator method that allows us, it has public access, and only that method can change the value that is inside ID. And here we called the set ID method and we sent over the ID to change. Let's now do the same thing with first name, last name, and GPA. Try to pause the video, see if you can make these 3 setter methods on your own. Public void set first name. I'm going to send over string fname. And I'm going to say first name equals fname. So here I'm taking the fname parameter and I'm saving it into the first name data member. And I'm going to do the same thing for last name. Public void set last name, string lname, and I'm going to take the lname parameter and save it into last name. And then finally, public void set GPA, string grade point average, and I'm going to save that grade point average into the variable GPA. So you'll notice the number of data members you have, you will have twice that many combined accessor and mutator methods, or maybe better worded, for every data member you will have 1 getter and 1 setter method. So for ID, we have a get ID and we have a set ID method. For the first name, we have a get first name that returns the first name. It has no parameter because it's just returning the name. We also have a set first name method that receives a parameter and it sets the first name. So each one of your data members, you will have a setter method and you will have a getter method. It shows an error. I did a typo. I think I did. Let me just put this here. Oh, it's not a string. It is a double. So now that that's done, we can, instead of saying s1.firstname equals, we can say s1.set first name. And here we would put in Addison. And then here this would be s1.set last name. And we put the last name. And then finally s1.set GPA. And I'll just put the parentheses manually. And there we go. And so now that that is done, I could print out that student object, the details of that student object as well. Let me paste this, and I'll call this S1. and then copy paste this to each of these other locations. And now I can run this code. And here we go. We have, let me make a print statement. And so here, when we look at this output, system.out.print, there we go. When we look at this output, we have the first student that we made. And this time we use the no argument constructor, the default constructor, and we assigned 4 values now using our setter methods, our mutator methods. And then we printed the details of that student using our getter methods. So it's the same thing as last time, but now getters and setters. And then we made another student using a custom constructor that has 4 parameters. And then we, within that constructor, we saved, of course, those parameters into their respective data members. And then finally, we printed out the information of this second student we just created, once again using those getters. So what's next? What's next is we want to come down and stop doing things in a cheesy way. What do I mean in a cheesy way? So here, let's look at this set ID method. I'm going to zoom in. Cheesy way is the fact that I have the actual data member is called ID, right? The data member at the top, it's called ID. But notice as a parameter, I didn't call it ID as the parameter. And I didn't do this. Let me try that again. Instead, I called the parameter ID number. Now, the reason I called the parameter ID number is because we haven't learned to do it the proper way, which is what we're about to do. What is the proper way? In industry, in real life, you're not going to have only 4 variables. You might have 4 dozen variables, hundreds of variables. These variables will have very well thought out names. And it makes 0 sense to name your parameter a different name than this very well thought out name you came up with. In fact, if you've called your variable ID, or if you've called your variable first name, your parameter should also be called first name. It should not be called F name or L name. We only did that because, again, we didn't know the correct way of doing it. So I know it's going to seem silly. Just follow me here, though. Let's break down what's actually happening with this line of code, and let's write a detailed comment for that. What are we doing with this line of code? We are telling Java a command, take the parameter ID number and save the value inside that parameter into the data member ID. Is that clear? Take the parameter, which is ID number, and save the value that is inside that parameter into the data member ID. That's very clear. Everyone should follow along with that. Okay, well now, what if we call this what it should be called? Just ID. And we put just ID right here. The initial problem with that is Java is assuming, because ID is a local variable. Now, when we had it like this, Java assumed that this ID right here, because it's not shown anywhere else, it's not shown as a parameter, that when we typed ID, Java automatically knew you were referring to the data member ID. But when we put ID right here, and we put ID right here, now we have a local variable. This ID is a formal parameter. It's a local variable. And in fact, Java is assuming that you're trying to save this local variable into itself. This ID equals ID no longer is Java assuming you're referring to the data member ID. Right now, it sees this right here on the right side of the assignment. It's assuming that's the same ID as right here is the parameter. And even on the left side, It's assuming that's the same ID as the formal parameter. It's no longer connecting this to your data member, which is why it's confused, because it then says the assigned value is never used, assigning to itself. Basically, you could say int x equals 4 and say x equals x. I mean, you could say x equals x. It's not wrong, but Java's like, why are you assigning a variable to itself? I mean, sure, let's do that again for kicks. There's no value of doing so. So it's kind of weird. So Java's assuming that you're just on this line of code, that you're saving the parameter into the parameter. And you're thinking, but that's not what I want to do. Well, what is it that you want to do? What is it that we're really trying to do? We're trying to save the parameter, which we're calling ID. We're trying to save it into the ID of this particular object, of this data member up here, right? That's what we wanted to do. In fact, that's what we had typed out right here. We said, when we had this as ID number, we said take the ID number, the parameter ID number, and save it into the data member ID, and save it into the data member of this object ID. That's what we're trying to do. And let me even reword this. And save the data, save the value inside that parameter into the data member, into the ID data member of this object. That's what we're doing. Take ID number and save it into the ID data member of this object. Well, that's what we want to do even if we type ID right here, but it doesn't work that way for the reason already mentioned. And what's the solution? The solution is super easy, as long as we understand what I've written right here. So let's now change this comment and match it with what we have as a variable name. Take the parameter ID and save the value inside that parameter into the ID data member of this particular object. That's what we want this to do. How do we make it happen? By literally typing the word this. That now fixes our problem. Now, what happens is Java says, oh, right here, when you say ID, you're talking about the parameter ID. But on the left side of this assignment, when you say ID, you're talking about the data member ID of this particular object that you're working on. I got you. Now Java's like, I got you. So maybe that's an overkill of an explanation, but basically, in short, you don't want to use different names from your parameters. When you have getters and setters in your setter methods, you don't want to use different variable names from your actual data members. You want the exact same variable name. However, the consequence here, looking at this first name in summary, the consequence is Java is assuming right here that you're trying to save the first name, the parameter, back into the parameter, and it doesn't make sense. And you're thinking, no, that's not what I want to do. What you really want to do is take the parameter, first name, and save the value inside that parameter, the value that is inside that parameter, into the first name data member of this object. So how do you do that? You literally type the word this dot. So for each one of these, I'm going to put the correct variable name for even the formal parameters, and then we use this dot and we use this dot. I hope that makes sense. Let's now come back up to the constructor and let's edit the constructor in that same way. This is trash. We absolutely should not have ID equals ID number, first name equals F name. That is horrible. We should use the correct variable names, first name. And again, as I'm typing this, the only reason we did not use the correct variable names is because we did not understand this concept of using this dot. But now that we do, we can put the correct variable names here. and then we'll cover this once I'm done copying and pasting. And so each one of these lines, we need to have a this dot in front of. I'll just type it. This dot, and this dot. 5 times the charm. So here we go. We now have this new constructor. We've sent over the 4 parameters. The 4 parameters have their correct named variables matching up with the data members. And now, instead of saying, of course, first name equals first name, which is confusing because Java is assuming that you want to save the parameter back into the parameter, which is kind of weird. You're saying, no, Java, don't save the parameter into the parameter. Save whatever was sent over in the parameter. Save it into the first name data member of this object. That's what the this is, of this object. What do you mean this object? Well, think about it. We literally just commanded Java, make me a new student object, this object right here with those values. And what are we going to do with this 1112222? We're going to take that 1112222, which is going to be right here as the parameter, and we're going to save it into the ID data member of this object, the new object that we are just now creating. All right, so the very last thing is we want to talk about, and this was a question asked, and what is the main purpose of classes and objects? Think about that. What is the main purpose of these things? What we've seen from these last 2 videos, if you were to ask, what is the main purpose? I would suspect most students would have said the first thing is to group together all the data that would, in theory, belong to a particular object, because that's effectively what we've done, right? We have all this data, an ID, a first name, a last name, a GPA, and we're encapsulating, that's the OOP word, we're encapsulating, we're wrapping all of that data together. That is a huge purpose, absolutely, of objects and classes. However, I would argue the major purpose is to model the operations and the methods that we want to work on these objects. This is really the other major purpose, if not the main purpose of objects and classes, to be able to have operations that we're going to then use and behaviors that we want to model on these objects. So the example that is often given is we think about a basic string object. String S equals computer. That's a basic object with only one thing inside it, but when we type S dot, we have all of these methods that are available to us. All of these operations that are really part of that string blueprint, that string class. And this is really where we get the power of classes and objects that we create from those classes. So with that in mind, I'd like to end by making one particular method here within this student class. What if we want to make, so we've done here, we have our data members, we have constructors, we have accessors and mutators, and let's end by putting a comment. Let's call this other methods. And let's make a method called public void, and this method is called print details. It doesn't receive any parameters. This method simply prints the object in question. So what if I just could say, instead of up here, instead of printing all of this individual information, what if I could just say instead s2 dot print details? And what's going to happen is all of the details of student 2 would get printed. How? I'm going to take these 4 lines of code and I'm going to come put them inside print details right here. Now there's some errors and we'll fix that in just a moment. And I'm going to do the same thing up here. I'm going to delete these 4 lines of printing. And instead, I just want to say s1 dot print details. So we're now offloading the printing of the details of that student object into a method that belongs to the student blueprint. So we're in the student blueprint. We've made this method called print details. And what are we doing? We're saying, hey, go print the ID in the first name. Now the error is because we were in main, we were saying print s2.getID or s1.getID. Well, here we're no longer in main. We're actually inside the blueprint. And so I can delete that s2 or that s1. And when I say s2.print details, what's happening? This is a particular object. Which object? It's this object here. s1.print details, we would expect it would print the details of this object, right? So this print details method, it's intrinsically connected to the specific object from which you're calling it. So if you typed s2.print details, you would expect to print this information, obviously, whereas s1.print details, we would expect to print this information. So I got rid of the s1 or the s2, and in fact, because we're actually inside the student blueprint, I don't even need to use getID. I can, there's no harm to put getID, but I could just directly type ID, because remember, ID is private and it's only accessible from within the same class. Well, we're inside the same class. We're in the blueprint. So I can directly just type in first name or last name and then GPA as well. So now we have a print details method that we made. Pretty simple. It's just taking those print statements and I offloaded them into this print details method that is part of the class, part of the blueprint, and now I run the code and I get the same results. A lot of cool things we've covered. Main thing, getters and setters, followed by the second main thing, the idea of using this keyword to represent the specific object under question that's being operated on, and then the idea that we can really get the power of classes and objects when we begin to make our own custom methods to model certain behaviors. In this case, the behavior of printing data on a particular object. It's been fun. As always, reach out, leave any questions if you have some. Take care, everyone.